Everyone hear me? Yep. I'm Joey Arvato. I'm an information security engineer tied to Meta's data centers, and we're going to kind of walk through some of the work we've done in working to secure that space at an industry level, specifically a white paper we've produced in the past couple of months, and talk about the project overall. So I've got up here with me some of our core collaborators in the space. We have Eehern from Google, who is a device expert, I believe, right? We've got Todd from Schneider Electric, who is a systems architect, and we've got Michael Clark with the OPCU Foundation, who is Director of North American Activities, I believe. Yep. So let's kind of talk real quick about what OTS is, what the Data Center Facilities Operational Technology Project is, sub-project is. In data centers, we sit at the really weird intersection of where physical meets logical from a security standpoint. So to give a tangible example of this, I believe in 2020, there was a wastewater treatment facility in Florida that had an event. And as the course of that event, the chemical levels in the public water supply, the attacker was working to alter those. In this case, the facility was able to catch that attack and remediate it before they became an issue. But this is the place where information security and these systems that control our data centers can have real-world effects when something happens. So we started this project with the mindset of how can we better partner with our peers in industry, with our vendors, with other standards organizations to look at holistically where can we provide better security in the space. To date, we've divided the project up into about 3 work streams. One of those work streams is our physical security work stream, where we're trying to establish guidance on how to physically secure a data center at an industry level, which is something that surprisingly did not exist before, not from a holistic standpoint. Another one of our work streams is around secure communications. So from a network standpoint, what do we need from security in the space? And today, we're going to talk about logging and monitoring. What is device criticality? How do we prioritize devices based upon their use case in the environment? So I tend to be a pretty traditional information security guy from an IT background. And when you look at information security from an IT background, there's quite a bit of maturity in the space. Things that we cannot do on OT networks, like scan for vulnerabilities, we are capable of doing in IT very well. We have a lot of tech debt in the OT space. OT equipment has traditionally been designed with life safety in mind, right? A fire suppression system cannot go offline. It has to be operational. There is a life safety event if there's a problem with that. So that has to be a primary design point for those systems. Longevity. This equipment that goes into our data centers can be there for decades. I worked in manufacturing where we had 100-year-old equipment that was still going prior to Meta. So this equipment has an extreme longevity, and our vendors often design for those needs. But as we've seen attack surfaces change, we've seen different groups become more enabled in the space and grow greater capabilities. We're now at the point where information security can also become a life safety issue with this equipment. So traditional IT, laptops, servers, OT, we're looking at the equipment that powers our facilities. They enable our compute and network capacity that we need in place. To kind of talk about one of the interesting attack vectors that you can see that may sound hypothetical, but it's not. If you look at how we ingest air into our data centers, we pull in air at variable speeds based upon how much cooling we need in the space. And then we exhaust that once we've run it through our systems to provide cooling. Well, if you ramp those fans up to their highest speed and you shut your air baffles down so you're no longer exhausting that air, you now create pressure in those buildings where the buildings can have physical damage to them. So these type of attack vectors are things that many people don't expect in the space, but they're real-world consequences to systems where we have some tech debt, where we need to do better so we can enable better security in the space. I'm going to hand it over to Todd.
So we began this white paper by just kind of blasting out some requirements, brainstorming the types of devices we see in data centers. We kind of arrived at 3 different categories. So security relevant features, the first one, things like authentication, authorization, user access, those types of things. The second bin that as we went through them was configuration data. So classic example of firmware. What firmware do I have? What version do I have? There's many different versions that I could have across a single given device type. So other things like network links and device identifiers, what type of device am I, those sorts of things. The third bin we saw was data quality. So do I have ranges that are out of range that I expect? Alarms, is there things that I need to be alerted of? And then as we went through this, we kind of said, well, let's step back a little bit. The Purdue model was something that we kind of applied to this use case. The different levels, level 0 being sensors, things that are like a CT or something that might not have an Ethernet port in it. Level 1, sitting above that, would be things like PLCs that might interact with those sensors, kind of differentiating those 2 levels. All of that reporting up to kind of level 2, level 3, where you'd find EPMS, BMS systems. So this is a means of classifying the types of devices that you'd see. And now the requirements that we'd built, we could kind of look at applying those to this classification. So the next level of classifying was introducing, similar to Joey, talking about the criticality of these assets. Not all of them will be as critical as the next. He gave an airflow example. Another example might be a circuit breaker status. If I have a utility main incomer, that's a lot more critical than a circuit breaker that might be open further down in my power system. So we classified the devices in the data center and what level they might sit at. That's what we called the system classification here. Then we introduced 2 other sort of levers, the functional objectives. What is this? Does this have environmental, human safety, sensitive information? Where does the particular asset fall in that category? And then blast radius, or the extent. And you can kind of see, gives us a means to see how critical one asset might be versus a next. Eehern's going to dig a little deeper into the device criticality.
Did you go for this one? Or did I miss it?
Yeah, go to the next one.
Okay, so I guess to put it all together, we want to look at, depending on the device criticality, how can we take that to determine what types of risk mitigations, what types of events and monitoring requirements we want to apply to that device. You can think of it from context, or from the perspective of a vendor. You might say, like, I have this device, how many features do I want to include in it? And it's going to depend on, like, well, what are my customers using it for? Are they going to use it for A, B, and C, and D applications, or just A, right? And if it's going to be used across a wide breadth of applications, you want to be able to have a lot more features to apply for it. From the context of a customer, you might say, I'm only using it in application A, and so I may not require all the requirements. So depending on sort of the context, you may actually decide that you may need more or fewer mitigation techniques or event and monitoring requirements. The way we kind of go about this is we figured we can evaluate device criticality based off of a risk assessment matrix. That's sort of the pre-filter. That's a way for us to decide right off the bat, should I even look at this part of the stack, or should I move on? Because there's so many things in the data center stack, and it would be intractable to evaluate everything. So what our risk assessment matrix is a simple table that says, all right, what is the extent, what is sort of the occurrence of it, and if it's high, then we go evaluate. If it's low, then we move on to the next piece. Again, like, both the customer and the vendor can use this, right? again, going back to like the perspective or context, like a leak detector, for example, if a leak detector from a vendor perspective may be used for both health and life safety as well as infrastructure safety. If you're designing it for both health safety and IT safety, then you might have a lot more requirements than if you're actually using it for, say, IT safety or just a pure monitoring application. So context matters, and this is really just setting the framework for how, depending on who you are, how do you evaluate the criticality of devices and what mitigations to apply. So what our risk assessment matrix looks like is pretty simple, right? Like if there's not going to be a lot of damage, then you may not want to apply any type of mitigation. But if there's some extensive damage or some regular occurrence of that damage, then you really have to look a little bit more closely. And once you get into the red area, you start wanting to look more closely on which types of requirements are applicable. And that's where we move on to our framework, where we kind of talked about topology, function, and extent. These are kind of the orthogonal metrics that we look at, right? Topology was the Purdue model where we have, whether you have a device on L0, L1, L2, L3, if it's very far away from, say, your facilities network, say on its own private serial network, it might not be something that you worry as much about, right? But if it's something that spans your entire BMS or PMS or like your SCADA system, that's something where it's going to be much more important to look at some of these mitigation or event and monitoring requirements. So this table is kind of looking at one particular requirement, which is authentication and authorization, and kind of using as an example to look at topology, function, extent. Right, so for topology, right, like it's required if it's at the higher levels, if it's at the lower levels, like in this case of a leak detector, you may not need it, right? A leak detector also depends on context. Like if you're using it behind a PLC where it's really on its own private serial network, then it may be optional. If it's on the facilities network, it's perfect. If the leak detector is on the facilities network directly, like with Modbus TCP/IP, for example, then that would be something that you actually want to start adding a little bit more requirements on top of, making sure you have a lot of these features that are relevant. Okay. And then the second function, we kind of talked about life safety versus like information security or physical security and things of that sort. So that's just another way to evaluate our metrics. And finally, extent. Is it going to damage one machine? Is it going to damage the entire campus? That's going to have different requirements on whether you look at all the different requirements or not. So that's sort of the framework that we set up. And we have a list of different event and monitoring requirements that sort of fit within those three buckets that Todd alluded to. And this is just kind of the way that we're going to address it.
This is our last slide, the call to action. So we've spent quite a few minutes on calls together building the first iteration of this white paper. As you can see, it's higher level, kind of the why, the what, the QR code that Eehern has pasted into the slide there. We'll let you kind of browse through that first version of it. We're currently in the process of the second version of the white paper where we'll dig into more of the nitty-gritty, the details, start to include the how we introduce better security into the devices that go into data centers. Always want more contributors. We have hyperscalers, we have vendors, we have OPC, Redfish. We want more. My contact information is here, and if you would like to contribute, we would love to have you on the biweekly calls. So yeah, please feel free to reach out. Yeah, questions?
Hi there. I'm really curious how Redfish is involved in this effort, particularly at the lower levels of that stack, that topology stack you showed us.
Right, so they're going to be more involved with the second iteration of the paper where we're kind of being a little bit more prescriptive and like what are the information or data models going to look like, right? Like Redfish is pretty well established in the IT world and we want to kind of expand that to like specific data center equipment. So part of the actions for the next white paper is to kind of dig into like what are some common devices, common attributes that we can apply and kind of bring in models from different associations and make sure they all kind of work together. So Redfish is kind of involved to fit within that framework.
Any other questions?
Thank you all for listening to us talk about our project. We are firm believers that the more perspective we have in the project now, the better it will be in the long term. So right now we have fantastic partnerships with vendors, consumers, standards, and we're working to drive more impactful work in the long term. But we want more perspective in our team. So one hyperscaler may have a very different set of views and needs than another. So the more engagement we get, the more perspective we can add to the work, the better we can adapt to the needs of industry as a whole. Our vendor community, we're really going to be looking to them to build to the standards, to build the equipment, the systems that we are deploying. Most of us in the hyperscale community aren't going to go out and design our own systems, right? We're going to rely on our vendor community to do that. And so we need our vendors in space that can help support that. Our vendors also have their own needs, kind of as Eehern talked. We may buy a leak detector and have one use case for it. Our vendors aren't going to build to one use case for one customer. They have to build to everyone. So as we establish these requirements, it becomes really important for us to keep context that there are needs from both sides of it. And from our standards boards, this is how we really make sure that we have a level of adoption, that we have a level of viewpoint and review from peers and other groups to establish these are the right control sets, these are the right data models that we need moving forward in the space. So we're always looking for more engagement. We always would like more perspective. It will only help make the end product stronger. We would love to have anyone in this room or anyone else kind of hop in and start adding views and perspectives to the project.